All right, so we're going to talk about 11.3, which is surface area in this video. There'll probably be multiple videos just because it's kind of long. Usually we break 11.3 up in two parts in class. So the first part is surface area, and then that's an entire class period, and then there'll be another class period devoted to volume. So there'll be quite a few videos for both of these to kind of go through everything. I actually think surface area is more complicated of the two. It usually takes a little bit more work and a little bit more space up on your paper. So we'll jump in and get that one done first. So surface area is essentially just the area of all the outside spaces of a 3D figure. So for example, if you had a tent, if you were to disassemble the tent and take the area of the bottom of the tent and all the sides of the tent, and add up all of those areas, you would get surface area. Or, if you were to take a soup can and kind of disassemble, it has it has a round top, a round bottom, and then the side. If you were to find the area of all those parts, and add it together, that would be the total surface area. So because we're finding area, we're going to be working in square units. So that's an important thing to note. So square units, and those are units like square meters, square feet, square inches, etc. So we're going to start by talking about the surface area of a prism, but you're going to find that, with all of these figures, really all we're doing is we're just breaking it apart and adding up all the different all the surface or the areas of all the parts. So add up all the areas. I'm just going to add that part of the faces and bases. So what's really important in this unit is to be able to identify what is the shape of the side, what is it called, and then what is the formula. And it may be helpful to get out your note sheet. Hopefully you have one. If not, start one. But start a note sheet where you list out all the area formulas. For example, a triangle. So we have height and base. So area of a triangle is 1/2 times base times height. Area of a rectangle is base times height, or length times width, however you want to think of it, where they're perpendicular to each other. So we've got a height and a base. We have a parallelogram, okay, and the area is also base times height, where the base and height are perpendicular to each other. There's a trapezoid. Okay, trapezoid has two parallel sides, and the area of a trapezoid is 1/2 the height times base 1 plus base 2. So this is the height. It's perpendicular to one of the bases. So we've got base 1 and base 2. And let's see, and then we've got a circle. So area is pi r squared. And I think that pretty much covers most of them. If I'm missing any, I'll come back and add to it later. So let's go down here. We're going to scroll down, and we're going to find the volume of this prism. Or not the volume, that's a typo. So cross that out, and we're going to find the surface area. And it's an isosceles triangular prism. And that's important. And I meant to put that in the notes, but just left it out. So the reason why it's important is because you have to know that this is an isosceles triangle. Otherwise, you wouldn't be able to do the problem. So if we basically imagine taking scissors and cutting this figure apart. So there are two bases. Okay, so the bases are these matching triangles here. And I'm going to draw those out. So we've got one. And we're going to say, I'm just going to write a times 2 because there's two of those, okay? You know what, actually, let me just draw that out so that way it's really clear. And then we've got the lateral bases, or lateral faces, which are basically just the sides, okay? And there are 3 rectangles. So we've got the one side, got the other side, and we have the bottom. Okay, so we'll call this the bottom, and we'll call these the sides. Okay, and so let's look at the triangular bases, and I'm going to label what I know. So I know that this is 4, and I know that the height is 3, and I know this is the height because I see that little right angle symbol, which is great. So I could go ahead and find the area of that triangle. So I'm going to write down the formula for area of a triangle. Area is 1/2 base times height. So I'm going to say 1/2 times the base, which is 4, and the height, which is 3. And so I get 1/2 of 4 is 2. 2 times 3 is equal to 6. So I know this has an area of 6, and then this has an area of 6. Then let's go to the sides. So I can look at, let's do the bottom first, because that one's a little bit easier to tell. So the bottom, I could use a different color here, and this is actually nicer than when I'm in class. So the bottom, I'm looking at right there, has a length of 10, okay, and it's got the other dimension, looks like it's 4. So 10 times 4 would be 40, and I'm multiplying because the area of a rectangle, we multiply length times width. Okay, now let's look at the side. So if I look at this side right here, okay, it looks like this long side is 10, but I don't know what that width of the rectangle is right here. And the way that I'm going to find that is by looking at the triangle. So if I look at the triangle again, I'm going to draw the triangle one more time. I know that this is 4. I know that the height is 3. I'm basically trying to figure out what is that dimension there. And I can actually use Pythagorean Theorem because I have a right triangle. And the reason why we were told this is an isosceles triangle is because with isosceles triangles, these two sides are the same, which means that this has to equal this. So instead of writing a 4 at the bottom, I'm actually going to break this up into 2 and 2. And so what I'm going to do is I'm just going to look at the one triangle to the left, and it really doesn't matter which one I look at. It could be the left or right, but I'm just going to pick the left, and this is a right triangle. So, and I'm going to use the Pythagorean theorem, which is a squared plus b squared equals c squared. And c squared is always the longest side of the triangle, so that's what I'm trying to find. That's my question mark. So I'm going to write 2 squared plus 3 squared equals c squared. And I'm going to erase this down below here just so I have a little bit more room. And so I get 4 plus 9 equals c squared, 13 equals c squared, and then take the square root of both sides, and I'm left with the square root of 13. So c is equal to the square root of 13, which is right here, square root of 13. So I'm going to also label my rectangle. So instead of a question mark now, I'm going to write square root of 13. And it's also, because it's isosceles, this other side is square root of 13. So when I'm looking at this back side of my tent, this is also square root of 13 by 10. So these are identical triangles. So square root of 13, if you use a calculator, is approximately 3.6. So if I just write approximately here, we're going to multiply 13.6 or 3.6, sorry, times 10. So we're looking at an area of about 36 for these. Okay, and so if I add up all of my areas, so at this point I'm going to, let me draw an arrow right up here. So my total surface area, I'm going to go ahead and I'm going to find all of the areas. So I've got 6, 6, 36, 36, and 40. So 6 plus 6 plus 36 plus 36 plus 40 is equal to 124 square centimeters, and that's going to be my surface area for that prism. Now, the only thing, I'm just looking at this thinking, gosh, what questions would there be if we were in class? One question might be, when you're doing the square root of 13 and you put that in the calculator, how do you know to round that to 3.6? Well, the nice thing about the homework is I put in a tolerance, an answer tolerance, so it should allow answers plus or minus about 2%. So that means you're okay rounding like that, and you shouldn't get your problem marked wrong. But if for some reason it is marked wrong and you're really, really close, you could always just send me an email. So let's look at the next one. So with the box, let's just take that apart. So it looks like we have, I'm just going to use a different color here. We've got two, what looks like squares. Okay. And so, oh, and it is a square actually, because we're told the height is 10 and the width is 10. So we've got two squares. So I'm going to draw those out. And you know what, I'm just going to keep this in red so that we can identify that easily. So these are both 10 by 10, so I'm going to write 100 in the middle because the area of a square is length times width, so 10 times 10 is 100. So those areas are 100, and then it looks like I've got, let's see, 4 sides. So that side is 10, the bottom is 10 by 15. And if I look at this side, this is also 10 by 15. And this would also be 10 by 15. And then this side would be 10 by 15. So I've got 4 identical rectangles. So we've got 1, 2, 3, 4, and all of these are 15 on the long side and 10 on the short side. So if we multiply 15 times 10, we get 150. So the area for those is 150. And if we add all of those numbers up, so 100, 100, 150, 150, 150, 150, then we get a total of 800 square centimeters for our area. All right, so that's those are the examples we're going to do for the prisms. Now let's think about the area of a cylinder. Now if I were, whoops, too much scrolling. Okay, so if I were in class, a lot of times what I would do is I would take in, like I have an oatmeal container, like a Quaker Oats container, which is a cylinder, and I take the top and the bottom off. So I break it up. So if you think of the cylinder being broken up into a circular top, a circular bottom, and then I cut with scissors down like this, and I open the container up, and it's hard to flatten out because it's been a cylinder its whole life, but if you smush it, what it looks like is a rectangle. And if you think about this, well, if we were to break it down just like we did the prism and find the area of the two circles, well, each circle is pi r squared because that's the area of a circle, okay? And then this rectangle, okay, has a height of whatever the height is of the cylinder, okay? So we'll call this h. And then the length of the rectangle is just the distance around the top of the cylinder, and distance around a circle is just circumference. So if we look at, if we just write down the circumference formula, circumference is 2 pi r. Okay, so let's write down, if we were to find the area of all of these pieces, what do we have? Well, we have 2 areas of circles, so 2 pi r squared plus the area of this rectangle, which is 2 pi r times the height, h. And so in your notes, you could probably fit it all into this ribbon, but this is what you want to write down. So the surface area of a cylinder is 2 pi r h plus 2 pi r squared, or the other way around. So let's do an example. So we're going to write down, and every single time I do these, I just get in the habit of writing down the formula. So, oh, and you know what? I'm going to write it down like this, 2 pi r h. It really doesn't matter what order, but I'm looking right now, and that's the order that I had it in on the notes that you have. So let's write it like that. So basically, I'm looking for the radius, and I need to find the height. So the height is 10. Okay, keep in mind the height, don't think of it as how tall it is. Think of it as how far are the bases away from each other. And I actually put that right in here in the notes. So how far apart are the bases? I say that because what if you got a cylinder that looked like this, where it was on its side? The height would be this distance right here. Okay, so that's 10. It's how far the bases are between each other. So, and the radius, so right here we have our diameter is 5, so that means our radius is going to be 2.5. So at this point, I just plug and chug. One thing you will have to do though is you're going to either have to use, you can use the pi button in your calculator, or your the directions for your homework say to use 3.1416, so we're going to do it like that. But it should hopefully accept either one. And if for some reason it didn't, you could let me know and I'll give you credit. Whoop, I don't want to write pi. I'm going to write 3.1416, okay, times 2.5 squared. Okay, and so if you work that all out, I end up getting 196.35 square centimeters. And, you know, this goes probably without saying, but at any point I would pause the video, you know, and try to do the problem yourself, and then you could resume the video and see if you got the problem right. Okay, so the next one we're going to do is pyramid, and again we're going to take apart all of the pieces. So imagine this is a tent, okay? If you were to take this tent apart, you would have a bottom of a tent, or what I will call the base. So we've got this bottom base, and it looks like this, okay? Try to draw it like it's drawn here, and this is 8 centimeters. And then we end up with some sides of the tent. So I'm going to actually add here, find the surface area of the equilateral pyramid. Okay, and we're going to, and that's important, so it means that all of these are the same. And actually, you know what I'm going to do is I'm going to draw this over again real quick and make this look like an equilateral pyramid here. So we've got 8 and 8 and 8, okay, and so all of these sides are 8, and then we've got the sides of basically our tent. So because it's an equilateral pyramid, all of these sides are going to be the exact same. And you know what, let me just use a different color so it makes sense. So by sides, I'm talking about this side right here. So there we go. And then I'll use a different color. So this one right here. Okay. And then we've got the back of the tent, which is back there. All right. So the bottoms of all of these, okay, are going to be 8. So we've got 8 and 8 and 8. And if we want the area of a triangle, that's going to be 1/2 the base of the triangle times the height. Well, we know that well, I shouldn't say we know that it's 8. We don't. Let's draw a line though. It's likely going to be 8. And we can look at our picture here. We've got a line drawn in with a right angle, and we're told that that distance is 15.9. So the height of these triangular sides is 15.9. So I'm going to use my formula, 1/2 base of 8, height of 15.9, and I know that 8 and 15.9 are my base and height because those are the lengths that are perpendicular to each other. So I'm looking for that right angle. So I'm going to just erase this so we can see it here a little bit more clearly. But if you look at this line right here and this right angle, that's that 15.9. Okay, so when we multiply that all together, we get 63.6, but this is for one triangle, and we don't want 1, we want 3. So I'm going to say times 3 is 190.8. So that's the area of all 3 sides. So all 3 sides. Okay, so now we have to find the area of a base. So just like before, we're going to use the same formula. So 1/2 base times height. And, you know, we could call this the base if we wanted to, but we would also need this distance if that were going to be the base, and we don't know what that distance is. So we're going to put a question mark or a height, and we're going to find that distance. So the way we're going to find that distance is we're going to use the Pythagorean theorem, and if this is an equilateral triangle, then we can say that this is 4 and this is 4, and just like in the last problem, we'll look at just one side of the triangle, and we'll use the Pythagorean theorem for that. So we're going to do a squared plus b squared equals c squared. Remember that c is the longest side. So 4 plus the height equals 8 squared. So 16 plus 8 squared equals 64. You're going to take away 16 from both sides. H squared is equal to 48. Okay. And then you're going to take the square root of both sides. And then if you take the square root of 48, you get approximately 6.928. And you may be thinking, well, how did you know to round to 3 decimal places? Honestly, that was just what I chose. I feel like 3 is you know, enough decimals to give us some good degree of accuracy, but you know, it's enough and it's easy enough to write down. Again, you're going to have a decent enough answer tolerance in your homework that it really shouldn't matter too much. Like even if you put 6.9, you'd get that marked correct. So I'm going to come over here to my area formula, and I'm going to do 1/2 the base. Now I'm looking at the whole triangle. So I'm going to actually, let's start over. So the bottom of my tent here has a base of 8 and a height of 6.928. So that's what I'm going to come over and use for this height. It's the height of that triangular bottom of the tent. So times 8 times 6.928. And if I multiply that all out, I get 27.712 square centimeters. Okay. So that gives me my total for the bottom. Okay, so all together, so I'm going to come up here, so total surface area, and I'm going to write down the individual surface areas that I found. So 27.712, 190.8, and I'm going to add those together. So I get 218.512. Okay. And that's going to be, we're going to look for the units, centimeters, so square centimeters are going to be my units. All right, so let's scroll down here. We've got surface area of a cone. Now this one's a little bit harder to break down, but if you imagine like a party hat, for instance, it's going to have a circular bottom, and then if you were to cut this up, we're going to have something that looks like this. Okay, so we're going to add these areas together to get our formula. So the area for a circle is pi r squared, and if we think about, you know, the bottom of the party hat is really just the distance around the circle, and the distance around the circle is 2 pi r. Okay, and this looks almost like a triangle with a rounded base, and if we were to find the area of a triangle, we would need this base, this 2 pi r, but we would also need to know the height. Well, the height of this triangular party hat is this distance right here, which we are going to call L. L is the lateral height. Okay, it's not the height. This is the actual height of the cone, but lateral height would be the distance on the side there. So this is going to be called L. Okay, and so if we use our formula for a triangle, 1/2 base times height, we're going to do 1/2 2 pi r times L, and then if I simplify this, we get pi r L. Okay, and so we could write our formula as pi r L plus pi r squared. And it's not important that you know how to prove it like I just did. You're not going to be asked to on a test. I just explained that because sometimes it's nice to know where formulas come from. So there is a formula in your book. I will write it here in case you're interested. It's basically the same formula, but it's written a little differently. So let me just write it down and I'll explain. You're probably thinking this does not look the same. I would suggest just using this one because it's a lot simpler and you can derive it. This formula is also another option, but basically what it does is it uses the Pythagorean Theorem embedded in here in case you don't know what L is, and I'll explain that a little bit later. Well, actually, I won't need to in this video, but when we get to volume, you know, we might. But either one will work, but I would suggest using the first one. So let's look at this next example. So we're going to use 3.1416 for pi, just like we did with the cylinder, and I'm going to write down my formula. So surface area for a cone is pi r L plus pi r squared. Again, L is the lateral height, and it's 20 centimeters in this problem. If for some reason you were given a cone where you weren't given the lateral height, but you were given the height of the cone. Whoop, let me draw that again. That was a bad picture. So let's say you're given this distance of like 10, but you did not know what that is. What you could do Okay, let's say you also knew this distance. You would have to use the Pythagorean Theorem to figure out what the lateral height is, and that's where, or you could use the second formula, but just a heads up on that. So that's not the case in this problem. In this case, we're given the slant height, so slant height is 20, and the radius is 12, so it's really just a plug and chug. So we're going to put in 3.1416 for pi, and then 12 for the radius, 20 for the slant height. Okay, and then when we work that out, we get 1,206.4 centimeters. All right, and last but not least, surface area. Now this one's harder to prove. One thing I will say is if you were working with students in a class, one option with surface area is to use an orange, which are pretty, almost perfect spheres, and you could have students peel the orange and use the orange to estimate the area, and you'll find that you can actually prove that it's really close to 4 pi r squared. And again, we're using pi as 3.1416. Okay, so for this, for example 5, this is the simplest of all. We just identify the radius as 5.2, we write down our formula, and then we plug and chug. Okay, and then we get approximately 339.8 square centimeters. I'm actually going to go through and do the exit problem. So this would be a really good opportunity to pause the video and do this yourself, and then restart the video and see if you got it right. Man, I need to really work on my scrolling here. Sorry, bear with me. Okay. I want to do this because it's a different shape than we've talked about so far. So this is a trapezoidal prism that has 2 bases. So the bases, well, all prisms have 2 bases, but the 2 bases are right here and they're trapezoids. So I'm just going to draw those out. So I've got 2 trapezoidal bases and they're identical. Okay. So I'm going to label what I need to know about my base. So or my trapezoid, which is a base. So it looks like the base 1, we'll call it, is 9 centimeters. So that's this distance right here. And it looks like this distance we can come up here is 4. So we'll call this 4. And I'm only going to label one trapezoid since these are the same. So these are the same. Okay. And then with the trapezoid formula, so area of a trapezoid, we're looking at 1/2 times the height times base 1 plus base 2. So I need to know the height of the trapezoid. So this distance, actually I'll do it down here, and it looks like that height of the trapezoid is 6. Okay, so we're not talking about the height of the prism, we're talking about the height of the trapezoid because we're just looking at the trapezoid right now. So I've got everything that I need to know, so I'm going to use my formula for area of a trapezoid. So I've got 1/2 times the height of 6 times base 1 is 9, base 2 is 4. So I work that out and I get an area of 39. So that means this area is 39 and it means this area is 39. So I have 2 39s. So now I'm going to come down here and I'm going to identify, well, what are the other sides? So it looks like, so I've got 4 sides. So I'm going to use some different colors here. So let's look at this side right here. So I'm going to draw that out. It's a rectangle. Okay. And it looks like the bottom of the rectangle is 9 and the height is 15.4. And if I multiply those together, I get 138.6. Okay. So now I'll just erase that and I'll look at the left side. Okay. So we could call this, actually, let me just label this. I'm just going to label it just so I keep track of everything. So now I'm going to do looks like kind of the left side here. So that's also a triangle and it looks like the bottom is 6.5 and the height, it's not labeled here, but it's the same height as the prism, so it's 15.4. So I'm going to do 6.5 times 15.4 and I get 100.1. Okay, so now I'm going to go ahead and I'm going to do the back. So this rectangle right here, which looks like it's 4 by 15.4. I know it's 15 by 4 because of that measurement right there. So I'm going to draw another rectangle, and these are not to scale. I know they look all the same size, but they're really not. So 4 by 15.4, and this is the back. So 4 times 15.4 is 61.6. All right, and then I'm going to do that right side. So this is the right side, and I'm going to draw a triangle for that one, and it looks like it's 6.5 and 15.4, and if I multiply those together I get 100.1. So that looks like it matches with the left side. So now what I'm going to do is I'm going to add everything up, and that's going to be my total surface area. So my total surface area, we're going to add the 39, 39, this number, this number, this number, and this number. So total surface area, when I add that up, is 478.4 square centimeters. So you can see here, I think I have an advantage with different colors, but you can use that. Also, I would highly suggest, make sure you draw every piece out. If you have to take out colored pencils or highlighters, that's helpful. And I think the more organized you can be the better. And if you have any questions as you're going through your homework, don't hesitate to ask. I'm here to help.